Welcome to the second video of Section 4, Creating Persistent Actors. In the previous video, we introduced Akka persistence and discussed the persistence architecture. In this video, we will implement a persistent actor. So let's get started with it. We want to implement a counter actor that handles two operations, increment and decrement. From the previous video, we know that a persistent actor handles two types of messages, commands and events. Commands represent operations from the outside world, and on the other hand, events represent stored operations from the journal. So let's define our operations. Let's add sealed trait for an operation which contains a number of variables. Then we add a case class for the increment operation, and another one for the decrement operation. Now, let's define command and event. We add a case class for command, which takes an operation as an argument, and another one for event. The last thing we need to define before starting the persistence actor definition is the case class representing our actor state, which contains a count variable. Now we are ready to start the definition of a persistent actor. To define a persistent actor, you should extend the persistent actor trait. Once you extend a persistent actor, you must define the implementation for three functions: persistence ID, receive recover, and receive command. Every message in the journal needs an identifier for his persistent entity. This identifier should be defined on the persistence ID function. And you should know that there must be exactly one persistence actor with persistence ID running at the same time, and the persistence ID should be unique. The persistent actor has two states, recovering mood and normal mood. For this reason, we have two receive functions, the receive recover function for recovering mood and receive command for normal mood. And your assumption is right. A persistence actor starts with recovering mood. So let's start with our implementation. First, let's add the identifier for our counter actor. Second, let's define receive recovering. It defines how a state is updated during recovery by handling event and snapshot offer messages, if snapshots were made for this actor. So let's define a function to update state, which takes the event as an argument and returns a unit. And for each case, we will update the current state. Let's return to receive recovering. We have two cases here. When receiving the event from the journal, we should update our state. And when receiving a snapshot offer message, we should take our state from the snapshot. The last thing we need to define is receive command. From the previous video, we know that the persistent actor, when receiving the command, it checks if the command can apply on the current state, or not, then generates the event from the command and persists it. So in our case, when receiving a command, we will generate an event and persist it. The persist method takes two arguments, the event that will persist on the journal, and a handler which is called on successful persistence. So if the event is successfully persisted, we will update our state. Now, let's add an extra case for printing our current state to understanding. Here is our app object. We defined the system actor and an instance of our counter actor and send some messages. Let's run our app. Great, it's working. But what happens if we run our app again? Let's try. Yeah, our actor starts from the previous state, not from a clean state. Now this actor is a persistent actor. See you in the next video where we will play with the persistent actor. We will show how to take a snapshot and deal more with recovery.